Given the distribution, this is a normal distribution. Find the sufficient statistics for theta. Solution. Please, for more of this, you need to subscribe to this channel. If we are given this function, we are asked to find the sufficient statistics for theta. The first thing to do is to take the product sum of this function. The product sum of this function is stated as this, which is equal to, we can open this to give us 1 all over square root of 2 pi. From this, the product sum will give us this exponential negative 1 all over 2 summation, because this is x, we will have x i's, so x i's minus theta all squared. So this is what we'll get. The next thing to do is to recall. We can recall that from quadratic equation. For this, we recall that xi minus theta all squared. If we want to expand this bracket, we get xi squared minus 2 theta x plus theta squared. On the same vein, if we have summation of xi minus theta all squared, I running from 1 to n, we'll have summation of xi. That means if you're using this now to sum what we have gotten here, minus 2 theta summation of xi. If you sum a constant, you get n, so we'll have n theta squared. So it means the whole of this is equal to this. The whole of this is equal to this. So we can write as f of x theta is equal to, write this one, 1 all over square root of 2 pi n exponential negative 1 all over 2 in brackets. This is up. So we, in place of this, we'll put the whole of this. We'll have summation of xi squared minus 2 theta summation of xi plus n theta squared. So this is what we'll have. We can as well open this to give us 1 all over square root of 2 pi raised to the power of n exponential. We can use this to multiply everything here to give us negative summation xi all over 2 minus, this is minus, we have plus 2 theta summation of xi all over 2. This is positive, so it changed to negative, n theta squared all over 2. This can cancel this. So we have 1 all over square root of 2 pi raised to the power of n exponential summation of xi squared all over 2 plus, this will now turn to theta summation of xi minus n theta squared all over 2. we should also note that exponential a plus b plus c is equal to exponential a multiplied by b multiply c. So we should note this. It means that if this is our function, we are looking for a way where we can factor this out. We'll have something like, from this we'll have something like 1 all over square root of 2 pi raised to the power of n exponential. We'll take this function, which is negative summation of xi squared all over 2. We combine this to give us exponential theta summation of xi minus n theta all over 2. So we can have our function as exponential, we'll bring this here, theta summation of xi n theta all over 2 multiplied by the whole of this 1 all over square root of 2 pi raised to the power of n exponential minus summation of xi squared all over 2. Why we couldn't separate this is because there is theta behind it. So there is no way, it will be very difficult to separate this function. But this one is devoid of theta. So we just have x here alone. So we can factor them out. This whole of this function, we can compare it with the factorization theorem to check if it is sufficient. So this will give us the function mu summation of xi mixed with theta, while this will now become our constant x1, x2 to xn. So this shows that summation of xi is a sufficient statistics for theta. So this is how we can obtain the sufficiency for the normal distribution that is given.